talk about bonding. Basically, there are three different types of bonds that exist within substances. There are ionic bonds, covalent bonds, and metallic bonds. Now, within these types of bonds, it really depends on what kind of elements are bonding together. So on the periodic table, we have metals shown here in pink, nonmetals shown in blue, and metalloids in yellow, which share the properties of both metals and nonmetals. So the type of bonding that will take place depends who are you putting together. Are you putting just metals together? Are you putting together just nonmetals? Or are you putting together a combination of a metal and a nonmetal? So what you need to know about this is that metals have very low electronegativities. They lose their electrons easy. These ones are barely holding on to those electrons. In contrast, the blue nonmetals, which are over on the right-hand side of the periodic table, with the exception of hydrogen. Hydrogen's a nonmetal. These elements, the nonmetals, hold their electrons really tight. They want those electrons held to them. So metals hold them loose, nonmetals hold them tight. What happens when we put them together? Let's start off with ionic compounds. In general, an ionic compound will occur if you combine a metal, something that holds electrons loose, with a nonmetal, something that holds electrons tight. So in general, these are two things with very, very different electronegativities. And for the most part, that is going to be a metal plus a nonmetal. Things that are on opposite sides of the periodic table. Now, if you put things very far apart on the periodic table that have very different electronegativities, what will happen is the metal's barely holding on to the electrons. The nonmetal pulls them really hard, and what will occur is that the nonmetal will steal the electrons away from the metal, one or more of those valence electrons. So electrons will be removed from the metal. I'm going to write that as an E minus and go on to the nonmetal. In that case, the metal will form some sort of a positive charge, and the nonmetal will form some sort of a negative charge, -1, -2, -3. And what we know about things with opposite charges is opposite charges attract, and we will get an ionic bond in between them for this attraction. So you should know ionic compounds occur between metals and nonmetals in general, things with very different electronegativities, and the metals lose the electrons, the nonmetals gain the electrons. Electrons were, in fact, transferred from the metal to the nonmetal, and then the opposite charged particles will attract. Okay, so that's ionic, opposite sides. What happens if you take things on the same side, same type of elements? For example, what if we combine two or more nonmetals? Well, that's when we get covalent compounds. So covalent compounds usually occur between two or more nonmetals. So what happens in this case is both of the nonmetals really want the electrons, so they're not able to steal electrons from one another. Instead, they need to share those valence electrons. Well, that's what the word covalent means anyway. Co means share, cohabitate, share a habitation, co-ed, share an education. So we are going to share the valence electrons. Now, when we do this between two or more nonmetals, not all sharing is equal. So let me give you two examples. Let's say you are bonding H with H versus H with F. H is a nonmetal, even though it's over on the left-hand side. The other H is a nonmetal. Two nonmetals, well, we're going to have to share those valence electrons. Now this H would not pull on the electrons in this bond any harder than the other H. So if the electrons are shared completely equally, then those electrons are not pulled towards one side versus the other. They're shared completely equal. There is no pull in one direction or another. No pull, we call that type of covalent bond non-polar. A non-polar covalent bond. No pull, non-polar covalent. However, between hydrogen and fluorine, they're not the same element. Therefore, they have different electronegativities. In fact, fluorine has the highest electronegativity out of all the elements altogether. So between them, if they're not the same element, rarely do they have exactly the same electronegativity. They're going to pull differently. So if they pull differently, think of this like a tug of war. H is pulling on the electrons in that bond. F is pulling on the electrons in that bond. They will get pulled to one side versus the other. If the electrons are shared unequally, and there is, in fact, a pull towards one side, we call that polar covalent. So to tell between nonpolar and polar, basically look at your nonmetals. If the two nonmetals are exactly the same, we're going to pretty much call it nonpolar, or if they have very, very close electronegativities. If there's a great big difference in those electronegativities, or if there is a difference, they're not exactly the same, but they're both nonmetals, then it most likely will be polar covalent. Polar, pull, nonpolar, no pull. Okay, so our last type of combination is we've done things on opposite sides. Opposite sides, we get opposite charges. Metal, nonmetal, ionic. Same side, both nonmetals, we call those covalent. What if it's just a metal? Well, if it's just a metal, we're going to go ahead and call that metallic bonding. And in metallic bonding, none of these atoms hold those valence electrons very tightly. Those valence electrons are actually free to roam throughout the metal structure. And sometimes they'll describe this as a sea of electrons. The electrons just get to roam and don't sit and they're not stuck on any one atom. So just metals, we're going to call that a sea of electrons type of combination. And again, in this case, the electrons happen to be shared, but this time those electrons are shared between metal atoms. Okay, I hope that helps, and see me in the next video and we'll do some example problems. Take care.